Okay, so let me just walk through the solution for the quiz, you guys. So problem number 1, the question was how much money should be invested in an account that earns 9% interest compounded monthly in order to have $11,000 in 4 years. So I think if you take a look, you'll see that almost every question on this quiz is either close to an example in class or it is a WebAssign problem, right? So here, this one, identify that the interest rate is 0.09, the number of compounding periods 12, the time is 4, and as such, we get this formula here, and is there a class in here? You guys are waiting for here, are you? Okay, okay. Thanks. All right, anyway, moving on here. So we want the future amount to be 11,000, so we end up with, A divided by 1 plus R over n to the nt is the formula we used for this, and that works out to $7,684.76, which was option B here. Problem 2, $350,000 home, down payment 20%. So what you do is 0.2 times 350, that gives you 70. You need $70,000 down payment. The mortgage is the cost of the house minus the down payment, which in this case is 280, so 280,000. So the answer was C, down payment 70,000, mortgage amount 280,000, right? So there's that. I hope that makes sense. I think, it's, whoa. I heard something flop on the roof. All right, moving on here. Problem 3. How many 3-letter words can be created from a usual 26-character alphabet? All right. So you could do, the counting principle, 26 for the first choice, 25 for the second, 24 for the third, which when you multiply them gives us 15,600. Or you could look at it in terms of permutations. There are, 26 choose P26 comma 3. There's that many arrangements of three distinct objects from picking from 26, right? So that also, of course, works out to the same number. No surprise there. Problem 4, you've got a special pizza with 5 toppings. You got 11 total toppings to pick from. One of you asked me, could you repeat a topping? And no, I should be clear. I mean, I'm sorry I didn't say it more. It would be better if I had written with any 5 distinct toppings. So like you can't have double mushrooms or something, right? If you wanted to count, if you wanted to count where you could repeat items, that would be more complicated, and that's beyond this course. But anyway, at least I haven't given you guys homework on that. So anyway, so 11 choose 5 is what we got to calculate here, and that works out to this, which calculates to 462. Problem 5, you got a snack bag of candies. If you count them up, if you add these numbers all up, you got 100 total candies. The number of candies we're interested, the brown or the purple, there's 18 of those. So 18 over 100 gives us the probability, or in terms of percent, probability times 100 gives us the percentage, right? And so the answer there was 18%. So I hope a lot of you got that right. I think that wasn't a bad problem. Oh, well, I'm trying to go on to the next page here. What's going on here? Oh, I'm sorry, my my bad. The solution pages got out of order, so you'll forgive me if I post it out of order. I think you'll figure it out. Anyway, page 6 here. Probability it will snow tomorrow is 0.32. What's the probability it will not snow? So this is the complement probability formula, 1 minus the probability. And so we get 0.68 is the probability it will not snow, all right? Brandon scored 70th percentile on a test given to 9,940 students. How many students scored lower than Brandon? Well, you just take 0.7 times 9940, you get 6958. There's your answer. So that many students scored lower than Brandon. It's kind of hard to believe. Let's see here. All right, problem 8. Find the area to the nearest thousandth of the standard normal distribution between the z-scores z1 equal to minus 0.56 and z2 equal to 2.24. So this right here is coming from lecture 14. If you look at the revised lecture 14, page 5, revised, I have made the theorem much more clear there. I made an announcement about this, and so I'm going to keep talking about that. But anyway, so you take the difference of the areas corresponding to those z-scores, all right? So I want a of 2.24 minus a of minus 0.56. But remember, if we've got a minus here, we pull it out. Minus minus gives us a plus. And then I look at the table. The table gives me 0.487 for 2.24z and area equal to 0.212 for z equal to 0.56, which when you add them together, you get 0.699, which is why the answer was B there. All right. Problem 9 is the cutoff problem. So I warned you that, finishing the homework would be wise before the quiz, and it's not the end of the world if you didn't, but if you didn't finish this homework problem yet, then of course this problem is difficult. But it's not impossible, and you can get it if it were to say, if something like it was to perhaps appear on the test again, right? But, so you want to try to understand the concepts used in this problem, okay? So we've got a mean of 63, all right? That's right in the middle. The score is 63. And the standard deviation is 10, all right? And the professor decides to give a grade of an A to students in the top 9% of the class. So I made a picture. So the blue shaded area corresponds to students getting an A, right? Which means that the other 91% of people are not getting an A, right? And so of that 91%, 50% are below the mean, right? And then 41% are above the mean. But the thing is, we can calculate 41% above the mean using the table, right? So 0.41 equals to a sub z, where z is going to be this z, right? The z that's at the cutoff. And so if I look at the table, 0.41 equals to az, it suggests that z is 1.34. All right, and so if z is 1.34, then we know the z-score formula says that the score minus the mean divided by the standard deviation is equal to 1.34. Multiply both sides of the equation by 10, we get 13.4 equals x minus 63. Add 63 to both sides, we get x equals to 63 plus 13.4, which makes my cutoff score 76.4, which is why the answer was D. All right. Now we have entered the world of the short answer problems. All right, so first one was you had a sample of 1, 4, 7, 8, and 10. Find the standard deviation and the mean. So I calculated the mean first, of course, because that's what you have to do, because you need the mean to calculate the standard deviation anyway, right? So you add all the numbers together, divide by the total number of numbers, which in this case was 5. So 30 over 5 gives you 6. And then I calculated the variation, which is, now this is a sample, so instead of dividing by 5, I divide by 4, right? So I have 1/4 of the sum of all these squares. So this is the first data point subtracted from the mean, the second from the mean, the third from the mean, so forth. And so you get these numbers, which when you add them up, you get 50, divide by 4, you get 12.5. That's the variation, which I didn't even ask for here. But if you calculate the variation, it's easy to find the standard deviation. You take the square root of the variation, and you get 3.536. There you go, there's your standard deviation. That's how you do problem 1. All right, so let me go back here. Problem 2, I gave you guys a giant hint about on the board. Remember, 500 factorial is 500 times 499, I think, factorial. So anyway, what you got to do here, because your calculator won't do this, right? It's too big for the calculator. You have to use the properties of the factorial. So 1000 factorial is 1000 times 999 factorial, but then these guys can't, whoa, yowzers. These guys cancel, and you're left with 1000. All right. So I did a lot of calculations like this in examples, so I hope that, don't completely ignore my calculations, because if you do, then you're, kind of living dangerously. You'd like to understand some of my calculations at least, right? As I say, sometimes you don't have to do all my calculations. Like sometimes you can use a calculator, right? But sometimes you can't. So like that's kind of the point of this problem, is we do need to know a little bit about how factorial works. I would have hoped you've had the definition of like the factorial on your formula sheet and such, but anyway, let's move on here. So calculate the mean, median, and mode of this given sample, 8675309. And okay, so I put them in order, ranked list, 0, 0, 3, 5, 6, 7, 8, 9. There are 8 of them, so I take the sum of them, divide by 8, I get 4.75, that's the mean. The median would be the number in the middle, but this is an even list of numbers, so what you got to do is calculate the average of the middle two numbers, which is 5 and 6. We get 5.5 for the median. The mode is 0, since 0 is repeated twice and nothing else is repeated with greater or equal frequency. So there's that. So that one's not, hopefully that wasn't bad. Hopefully a lot of you guys got that one. I think some of you are still sorting through this idea, this one, because you haven't quite finished the homework, and I'm sorry about that, but I have to have the quiz before the test, and sometimes there's just not quite enough time to let the material sit before the quiz. But anyway, here it is. So you had a biologist found the wingspans of a group of butterflies to be normally distributed with a mean of 51.3 millimeters and a standard deviation of 2.3 millimeters. Find the percent of butterflies with spans greater than 48.2 millimeters. So my first order of business is to figure out what the z-score of the number I'm interested in. So the z-score of 48.2, I take the 48.2, I subtract the mean, I divide by the standard deviation, and of course I get a negative z-score because 48.2 is smaller than the mean. So I'm looking to understand that. So what I'm really looking for is the probability that x is greater than 48.2, right? But the big theorem that we're using is that we can trade it for the probability the z-score is greater than minus 1.34, and we got a table for these, right? So then we see page 5 of the revised lecture 14, and it says you do 0.5 minus a of minus 0.34, and then you pull the minus out so you get to this. But if you don't like page 5 of lecture 14, you could just look at this picture here. So to get the area that's to the right of minus 1.34 z-score, I need all of this, right? So all of this, there's two pieces. There's the 0.5 for the purple, and there's this red part. And the red part, by the symmetry of the graph, is the same as a of 1.34, right? Now a of 1.34 I think of as being over here, but by symmetry, the area over here and the area over there are equal, if you can imagine that. But anyway, so I get 4.10 from the table, plus 5, I get 0.910. But notice it asked for a percent. I was just talking to a student today, we were getting the WebAssign problem wrong because we were putting in probabilities rather than percent. It does ask for percent in the WebAssign. So 91% have wingspans greater than 48.2 millimeters. Now, you got to think about this. Don't just try to just make this an algorithm. You need to think through it, understand the pieces. Like, how would you solve this problem if instead of saying greater than, I put less than right there? Could you still do it if I put less than instead of greater than here? How would that go? All right. Okay, anyway, so there's that one. And I think that's it for the quiz, all right? So we'll see what happened when I grade it. I wanted to give you guys an example of a regression line. So I took this from one of your WebAssigns, and I think it's either problem 7 or problem 8. I can't remember the number, but you'll recognize it. You're given a list of data, and you're asked to calculate the formula for the linear regression line. So the way to do that, it's like the last page on my lecture 14 slides, right? So what I did was I calculated the sum of xy, the sum of x, the sum of x squared, the sum of y, and the sum of y squared. And then I have to calculate the average of x and the average of y, all right? Once you have all of these things calculated, then you can go and you can use the formulas for the best fit line and also for the regression coefficient. So the first thing to do is to calculate all those quantities. Once you do that, then you go down here and you plug them in. So I have, n was for the problem we're looking at 5. I calculated the sum of xy was 44.5. I calculated the sum of x was 7, the sum of y was 42.7, and then I've got 5 times 27 minus 7 squared, which gives me minus 0.883. This is the slope of the regression line. Then b is given by y average minus a times x average. Y average was 8.54, and then minus a minus gives me a plus 0.883 times 1.4, which works out to about 9.78 for this problem. So my regression line formula is minus 0.89x plus 9.78, because the WebAssign said to round to the hundredths place, so I had to throw away a couple of the extra numbers up here, yeah? So like when I worked this problem with the student to start with, I got it wrong, and the reason I got it wrong is because I switched like the sum of y with the sum of x squared, personally. That's the mistake I made. And so like it's really easy to mess these up, and that's part of the reason I wanted to put this in the short answer part of the test, so I can give you partial credit if you've actually calculated these things correctly, and maybe you mess up something down here, but I can still see you're doing something right, and then I can give partial credit, right? In contrast, if I made this multiple choice, well, there's just, I don't know. I mean, it's kind of a hit or miss kind of thing, right? Now, the regression coefficient R is what I didn't talk about in lecture, but I was about to at the end. There's a note at the end of my last page on lecture 14 that says, discuss the linear correlation coefficient formula from the book, which is on page 799. And this is what it is. So this R describes how tight the best fit line is, basically, right? If R is equal to 1, it's a perfect fit. And then the further you get away from R, the worse it is. But anyway, so I plug in the numbers that we already calculated at the top of this page, and out pops minus 0.89. So that's how you do it. I mean, it's not especially exciting, but these problems in some sense are easier than like other problems like probability and counting permutations. You got a lot of like flavor choices there. You got to decide what you're doing. Here, there is a regression line. You get data points. You calculate the sum over x, sum over y, sum over x squared, sum over y squared, all these things, and you just plug them into the formula. There's actually less, there's more calculating to do here, but there's actually less thinking, which is why I thought it wasn't crazy to put it in this course, but maybe I was wrong. I wanted to share with you my WebAssign solution that it pops up. So like here is the corresponding problem in my web. It generates different values for everybody's different WebAssign. You get a different list of numbers if you're a different student, So like here's another one with 5 data points. This is the best fit line. This is the regression coefficient. Here's how WebAssign says to calculate it. Just what I was saying, right? Sum over x, sum over y, sum over x squared, sum over y squared, sum over x squared, sum over y squared, sum of xy. So, so the WebAssign actually takes the time to square the x and the y down here. I didn't do that before the calculation at the end. But if you look at this, all they're doing is just plugging the data points into the formula, right? So maybe this will help you. I'm going to post this along with the solution to the quiz so you can look at it if you're having trouble with those homework problems. So yeah, you just have to be careful with these numbers is what it boils down to. Let's see here. And also, one of you was wondering about interpolation versus extrapolation. And let me try to explain what's going on here. So this one here, you go through all of that rigmarole we just went through. You find the, the best fit line from this data, all right? That would take me about 10 minutes of calculation to get from here to here, okay? Well, okay, maybe 3 minutes if I'm really on the ball, but 10 minutes if I got to look things up and, get a cup of coffee, whatever. Okay, so anyway, you get this as the regression line. And then it says, use the equation from part A to estimate the remaining lifetime of a woman of age 34. So what that means is you plug 34 into this formula, right? Here, let me do it. So I'm going to take clear, 34 times, I'll put some parentheses here, minus 0.93, right? Plus 80.34 I get 48.72. And it says round to the nearest year, so we get 49 years. All right? Now, it says, is this procedure in part B an example of interpolation or extrapolation? So if you look at the range of the data here, right, what's the range of the, let's see here, it says, remaining lifetimes for women of various ages in a certain country. All right, so, the point is that if you look at the data that we're given, and if you look at the thing we're calculating, 34, right? Is that inside the data which is known? Well, yeah, 34 is between 15 and 35, right? It's between the data which is given. So that's an interpolation, all right? A extrapolation is something like when you have data that goes, say, from a certain range, like let's say you have data that goes from 0 to 10, right? And you find a best fit line that models the data from 0 to 10, but then somebody asks you to find out what happens at 20, right? So you're taking the best fit line and you're taking it from where the data is given, and then you're asking where does it go to out here. That's extrapolation. Extrapolation is when you use a model to say something about the unknown based on the data that you know, right? You use a model, fit the data that's in some sector that you know, and then you extrapolate beyond that. So extra as in beyond the data that you're given. Interpolate is inside the data that you're given, but you're just kind of connecting the dots like that. Now, anyway, I hope that makes sense. I don't think I did not test on, I will say this, I did not test on interpolation or extrapolation in quiz because I didn't talk about it in class. And I also did not test on the correlation coefficient because I did not talk about it in class, right? So in terms of this material, what I would expect on the test, if anything, would be the regression line formulas. Not the R part, but the A and the B part. So what I'm saying is, back here, well, let me go back here. So if I was to put a problem like this, on the test, I probably would just ask you, I would ask you to find this part. Like this part I think is fair game because I did cover that in lecture 14 and you had it in your homework too, right? But I'm not gonna ask you about this because I haven't talked about it in class in detail, and it's just kind of an ugly formula that I haven't really had a chance to blather on about too much. So let me stop talking about it so I don't feel like I need to test on it. But this part's not on the test. But this part up here very much could be on the test, all right? So I hope that helps make things clear for you. Anyway, enjoy your weekend. Hopefully we don't have a power outage in the test next Tuesday. Power went out here in DeMoss a little bit ago. See you guys.